So chapter 3 is about averages and variations. Let's recall that in chapter 1, we learned how to collect data. In chapter 2, we learned how to organize data on a frequency distribution table and how to present them using graph. So now we are going to learn the third aspect of statistics, which is computing averages and variations. This is called data summary. A data summary means that you compute those measures. So we will start with the measures of central tendency, which are the mode, median, and mean. When we collect data, as we said in chapter 2, raw data does not reveal too much information until we organize them into a frequency distribution table. But most of the time, we need some measures that could be useful in better describing the data. These are called measures of averages, that is a way to identify the center, and measure of variation, that is a way to determine the variability of the data. So we often come across expressions like, what is the average cost of housing in a locality? What is the average cost of gasoline in a state? What is the average shoe size of ladies, for example? The answer to each of those questions could be summarized as the central tendencies. The mode is the data value that has the highest frequency. That is the most frequent, the data that comes most often. The median refers to actual middle when you arrange data in order. And the mean is the arithmetic average, the way we actually think about it whenever we speak about average. The mid-range is a rough way of computing the average by taking the highest data and the highest value and the lowest value, take the average. So let's take this example. This example consists of counting the letters in each word of this sentence and give the mode. So the first word here is count, which has C-O-U-N-T. That's why we have the 5 here. Then the second word is the, T-H-E, which gives us 3 letters, L-E-T-T-E-R-S. So that is how I got these data values that we have. So what is the frequency for each of these values? And then what is the data value with the highest frequency is our question. So we scan the data, we see that 4 is the mode because more words have 4 letters than any other number. So when we have a few data values like these ones, we can easily determine which one is coming more often. When we have a large set of data, it becomes more difficult, and we will need to have either a frequency distribution table or use a statistical software such as Excel or your calculator. So another easily computed average is the median. The median is obtained by arranging data values in order and identify the middle. If you have an odd number of value, the median will be one of the data values. That is the one that is at the middle. If you have an even number of values, then you will take the average of the numbers that are at the middle. This is an example of data set. What do barbecue flavored potato chips cost? According to Consumer Report, the price is per ounce in cents of the rated chips are 19, 19, 27, 28, 18, 35. What is the median price? To find the median price, we will arrange these numbers in order. And we will see that there are 2 values that are at the middle. we take the average of these two values to get the median. So the median is 23 cents. When we have an odd number of value, we just take the one that is at the middle. So in this distribution, we will have the median will be 19. Now the arithmetic mean is obtained by adding all the values and divide by the sample size or the population size. To graduate, Linda needs at least a B in biology. She did not do well on her first 3 tests. However, she did well on the last 4. Here are her scores. So what will be her average in biology, the average that she will get? So to get a B, she needs to score between 80 and 89. Or a C is between 70 and 79. To find the average, we will add these numbers. We add the 7 numbers and divide by 7 to get 80. So she makes a B. When we compute the mean, we sum the given data. There is a convenient notation to indicate the sum. That notation is the Greek letter sigma, which means sum. So that symbol is generally used, and X bar is used to represent the sample mean. This is sigma here. I'm sorry, this is X bar for the sample mean. And for the population mean, which is the parameter corresponding to the sample mean, we use the lower Greek letter mu. We pronounce it as mu to represent the mean. So this is how we will write the formula. These formulas for sample and population are essentially the same. Add all the number together and divide by the number of individuals. If you have a question along the line, just stop me. So we have seen so far 3 averages: the mode, the median, and the mean. The disadvantage of the mean is that it can be affected by exceptional values. Those are values that are extremely large or extremely small. So the mean is not a resistant measure of the center. Unlike the median, for example, however you add values to the left and right of the data set, the median will remain the same. So the median is resistant to extreme values. So in order to resolve that problem for the mean, which generally is more useful in computation than the median, we can trim the values by removing the outliers, those extremely large or extremely small numbers. So for example, we can make a 5% trim. A 5% trim mean is obtained by determining what 5% is according to the sample size. That is, you multiply the sample size by 5% and round it up and take those values to the bottom and the top. So a 5% mean will actually result in removing 5% of the values to the lower and 5% of the value to the upper side of the data. We will remain with the middle 90% of the values. So when data sets are symmetric, the mean, the median, and the mode are the same. When data sets are skewed to the left, remember when we were looking at a histogram, skewed to the left meaning that there are more values to the right, the mean is less than the median, less than the mode, because more value are to the right. So that means the mode goes to the right, meaning it is bigger than all the other values. The median is always at the middle. When the data set is skewed to the right, the mode goes to the left and it's become the smallest of the values. And the mean is the highest of the 3. The median remains at the middle. So this is the graph represents what I'm talking about. For a symmetric mount-shaped graph, the median is equal to the mean and the mode. For a graph that is skewed to the left, the mean is less than the mode. For a distribution skewed to the right, the mode is less than the mean. So on a quiz question, you may have this organization. You can have a question like if a data is skewed to the left, then the mean is less than the mode, less than the median is less than the mean, less than the mode is less than the median, less than the mean, and you will have to choose the right one by recording what we are saying here. When we have data values that are organized on a frequency distribution table, we can easily make a computation by using the weight associated to each value. The weight could either be the frequency or actually a weight. For example, suppose your professor tells you that your grade will be based on a midterm and a final exam, each of which is based on 100 possible points. However, the final exam will be worth 60% of the grade, and the midterm only 40%. How could you determine an average score that would reflect these different weights? So to compute the weighted average, we assume that the weight is W and the score X will be multiplied by the weight, and we will divide by the sum of the weight. For example, suppose your midterm score is 83 and your final exam score is 95. Using a weight of 40% of the midterm and 60% for the final exam, compute the weighted average of your scores. If the minimum average for an A is 90, will you earn an A? So we will use this formula for the weight average, and we will do 83 times 0.4 plus 95 times 0.6, and then divide by 0.4 plus 0.6. We will get 90.2. So the average is high enough to earn an A. One of the measure of central tendency, which is not generally used, but which can also be considered a measure of central tendency, is the mid-range. It is obtained by taking the average of the lowest and the highest data value. So in this example, we have these values 3, 2, 4, 3, 4, 5, 7. So the mid-range is 7 plus 2 over 2, which is 9 over 2 equals to 4.5. Measure of variation, that is section 2. At the end, we are going to learn how to use Excel to do each of this work. While the measure of central tendency helps us to have a better feeling of our position with respect to the whole, we sometimes may want to know what is the unit of measurement of the distribution. How far actually are you away from the mean? So there are 3 types of variations: the range and the variance or the standard deviation. Sometimes we can also use the interquartile range. So the range is obtained by, we did the range when we were organizing data into classes. The range is the highest data value minus the lowest data value. Now to compute the variance, we first compute the mean. Subtract the mean from each value to get the deviation of that value from the mean and square it. So we will get a new distribution and divide the sum of the square of the deviation by n minus 1 when n is the sample size to get the variance. We are going to look at some examples. Here is another type of formula, which is just another variation of the formula for the variance. But since we are using calculator or Excel, it's not very important for you to memorize these formulas. Example, Big Blossom Greenhouse was commissioned to develop an extra large rose for the Rose Bowl parade. A random sample of blossom from hybrid bushes yielded the following diameters for mature pink blooms: 2, 3, 3, 8, 10, 10. Use the formula to compute the variance. This is just to show you how to use the formula. First, we compute the mean by adding all the numbers. We have 36 and divide by the sample size, which is 6. So we get a mean of 6. And now we subtract that mean from each data value and then square it, then add it up to get 70 and divide 70 by 6 minus 1, that is divided 70 by 5. This formula is the formula for a sample variance. So the sample variance will be 3.74. Now for population, we recall that the population mean is mu, and the population variance is sigma square. This is letter sigma square. For the population, the variance is the average of the square of the deviations from the mean. So the difference between the sample and population variance is that for population variance, we divide by the population size, but for sample variance, we divide by the sample size minus 1. The standard deviation is the square root of the variance. We want to remember this. We are going to use Excel later on to do an example so that in which we will compute all of the measures we have discussed so far. Coefficient of variation. Sometimes we want to compare two distributions to determine which one varies more. Commonly, we use the standard deviation as a measure of variation, and the distribution with the higher standard deviation is supposed to be the one that varies more. Now, it happened that most of the time, data are not of the same unit. Some data are in tens or hundreds. Some data could be in order of millions. So naturally, if you are working on a data in the order of millions, the standard deviation will be in millions. If you are working with data in 100, the standard deviation will be in the 100. And naturally, you will have the impression that the distribution, which is expressed in million, has a higher standard deviation because it is larger, yet it might not be true. That is why we use the coefficient of variation, which is a way to standardize the variabilities and compare them. So the coefficient of variation is computed by dividing the standard deviation by the mean and multiply by 100. Example, we are going to look at this example. The trade post on Grand Mesa is a small family-run store in remote part of Colorado. The Grand Mesa region contains many good fishing lakes, so the trading post sells spinners. The store has a very limited selection of spinners. In fact, the trading post has only 8 different types of spinners to sell. The prices are given below. Since the trading post has only 8 different kinds of spinners for sale, we consider the 8 data values to be the population. Are you guys having your calculator? We can use this as an example to learn how to use TI-83 calculator. Anybody has a TI-83 calculator now? Is any of you having a TI-83 calculator?
I do not have it on me right now.
Okay.
I
Anyone
have one.
you have one?
Yeah.
So let's quickly use the calculator to do this computation. I'm going to show you on PowerPoint how to do it manually. And because it is about the population, Excel only does it with for sample. There's no big deal. I always ask you questions about sample. If you want to see the same result as the one that is on your PowerPoint, you will use your calculator. This is just because calculator compute uh, both the sample and the population variance. So use your calculator, you go to start, you click on your start STAT, and then you press enter for edit. Now on L1, you will enter these values: 2.1, 1.95, 2.6, 2, 1.85, 2.25, 2.15, 2.25. So you enter these values into your calculator. Then you go back to start, press start, and then take the cursor to calc. And you will press enter twice. Then you have the mean equals to 2.14. The sum of all the values is 17.15. Calculator will give us all of these values. Now, the standard deviation is 0.23 for the sample standard deviation, and the population standard deviation is 0.21. Are you able to follow me?
Yeah.
Okay. Now I want us to use Excel to do the same thing. So everybody can use Excel. You go to Excel. I want to go to Excel now. So I am on Excel and I'm going to enter the data. You can enter it after me. We have 2.1, 1.95, 2.6, 2, 1.85, 2.25, 2.15, and 2.25. So we have the data on Excel. If you have the data on Excel, now click on data, and you will see to the upper right side of Excel, you see data analysis. You click on data analysis. If you don't see data analysis, let me know. I will help you to get it. Do you all see data analysis?
Yes.
So you click on data analysis, then you will choose the descriptive statistics. Then you click OK. So then you will highlight data and column A. And on the output range, you can just click anywhere you may want your result to come out at. Then choose summary statistics. And then you click OK. Now we have the mean here to be 2.14. Skip standard error. We are going to learn about that later on in chapter 6. Then the median is 2.12. The mode is 2.25, standard deviation. So the standard deviation and the variance that we have here are for the sample. Unlike on your calculator that it gives you both sample and sample variance and sample standard deviation and population standard deviation. On Excel, you only have it for sample standard deviation and sample variance. So that's why I wanted us to use calculator first. On calculator, you don't have variance. You have to square the standard deviation to get the variance. On Excel, what you have is for sample, is for descriptive statistics. Any question about using Excel? So once we have those two values, the mean and the standard deviation, we divide the standard deviation by the mean and multiply by 100 to get the coefficient of variation. So the coefficient of variation is 10.28%. So to compare two distributions, it is always better to use the coefficient of variation rather than using the standard deviation. Another concept in distribution is the Chebyshev's theorem. So when we have data values, we can subdivide them using the standard deviation. So I'm going to explain this using the whiteboard. Suppose this is a distribution. I'm giving you a common example of distribution, which is the normal distribution. Here we can say this is the mean. So we use the standard deviation as the unit of measurement. So we have plus standard deviation, plus 2 standard deviation, plus 3 standard deviation. Now, minus a standard deviation, minus 2 standard deviation, minus 3 standard deviation. So, for example, if the mean, let's say the mean is 5 and the standard deviation is 2, then within 2 standard deviation, we will do mean minus 2 standard deviation, which is 5 minus 4 equals to 1. And mean plus 2 standard deviation equals to 5 plus 4 equals to 9. So we will say that within values that are within 2 standard deviation are between 1 and 9. So the values that are within 2 standard deviations are between 1 and 9. What I mean here is this is less than or equals to, less than or equals to. So if you want to know the proportion of values that are within 2 standard deviation, multiply the standard deviation by 2, subtract it from the mean, add it to the mean to know the range of values that are within 2 standard deviations from the mean. So in general, statisticians are interested in knowing the proportion of values that are within a certain number of standard deviation from the mean. So the Chebyshev theorem tells us that within K standard deviation, K could be 1 or more than 1. K is generally more than 1 for the Chebyshev theorem. K could be 1.5, 2, 2.6, 2.3. K could be any value for the Chebyshevs. So to know the minimum proportion, Chebyshev is speaking about the minimum proportion. To know the minimum proportion of values that are within K standard deviation, you square K, take the inverse 1 over K squared, subtract it from 1. It will give you the minimum proportion of values that are within K standard deviation from the mean. For example, when K equals to 2, 2 squared is 4. And 1 minus 1 over 4 is 3 over 4. So at least 75% of values are within 2 standard deviation from the mean. Likewise, 1 minus 1 over 9 is 88.9. I'm 0.889 anyway. So 88.9% of values, at least 88%. I want you to pay attention to the at least that we are using here, are within 3 standard deviation, and 93.8% of values are within 4 standard deviation. So let's look at this example. A survey of local companies found that the mean amount of travel allowance for executives was 0.25 per mile. The standard deviation was 0.02. Using the Chebyshev's theorem, find a minimum percentage of the data values that will fall between 0.2 and 0.3. So the question is, what is the minimum proportion of values that is between 20 cents and 30 cents when we know that the mean is 25 cents and the standard deviation is 2 cents. So what we are going to do here is to do the reverse of the computation that we had before in order to get K. Before we had, let me use the whiteboard here. Here we have the mean is 0.25. The standard deviation is 0.02. So the question here is, if the Chebyshev interval is 0.2 to 0.3, what is the minimum proportion of values that are within this interval? So that's our question. What is the minimum proportion of values? That is, if you count the number of values that are between 0.2 and 0.3 and divide it by the sample size, what is the minimum value you should get? So we want to recall that within K standard deviation, this is the Chebyshev inequality, or the Chebyshev interval is x minus ks, that is within K standard deviation, x bar plus ks. This is a little mathematics. So look at what will happen here. If I do this number minus this one, what do I get? I will do this number, the upper number minus this lower number will give me 2 times ks. If I do the upper number minus the lower number, x bar is going to go. This minus here is going to become plus, and I will have x bar plus ks minus x bar minus ks is equal to So the x bar minus x bar will take the x bar away. The minus minus ks will make it plus ks, and it will give it me 2 ks, which is equals to 2 ks. K times s is 0.02. So I want to find the value of k. So that will mean 0.04 times k is equals to, now the upper value here is 0.3 minus the lower value 0.2 equal to 0.1. So k is equal to 0.1 divided by 0.02. So 0.1 divided by 0.04 equals to 2.5. So k here equals to 2.5. So now, another way to ask the question that we had on this example, we are going to go back to it and you will remember, is what is the minimum proportion of values that are within 2.5 standard deviation? So k square, now k square will be 2.5 square. And 2.5 square is 6.25. And 1 over k square is 1 over 6.25, which is equal to 0.16. Remember that the minimum proportion of values within k standard deviation is 1 over k square, which is 1 minus 0.16, which is 0.84. So this example had you are learning two important things here. First of all, the meaning of a Chebyshev interval. A Chebyshev interval is obtained by subtracting k times the number of standard deviation from the mean, adding k times the number of standard deviation to the mean. That gives you the Chebyshev intervals. The difference between the two values on a Chebyshev interval equals to 2 times k times standard deviation. So if you are given a Chebyshev interval and you want to find k, this is what you do. If you are given k and you want to find the Chebyshev's interval, multiply k by the standard deviation. Add it and subtract it to the mean to get the lower and upper value. That defines the Chebyshev interval. I will go back to the PowerPoint. So going back to the PowerPoint, we can see that 84% of data values will fall between 0.2 and 0.3. That is 84% of people spend between 0.2 and 0.3 on allowances for executive. We are going to look at some other measures of measures of data, which are called measures of position. So first, an important concept in statistics is the concept of percentile. The percentile rank of a number is the proportion of values that is at most equal to that number. For example, when we think at the median, the median will be the 50th percentile. That is, 50% of data are below the median, 50% are above the median. So generally, there is no exact formula for the median. One way to get the median is to take the relative cumulative frequency and to use it to determine the proportion of values that is at most at the value that we have. So if I tell you that 80%, that the 80th percentile is maybe 12, That will mean 20% of values are more than 12. So quartiles are used to divide data values into 4 equal parts. The first quartile is the 25th percentile. The second quartile is the median. The third quartile is the 75th percentile. We can think about it as quartiles, as the second quartile to be the median, which is at the middle, and then the median divide the data into 2 parts, a lower part and an upper part. The median of the lower part, which is also called the lower median, is Q1, and the median of the upper part, which is called the upper median, is Q3. The interquartile range is the difference between the third and the first quartile. Give us actually the distance between the middle part of the distribution. We are going to use an example here to illustrate all of that. So we have the following data values, which represent the number of children of 15 adults in a family meeting. So first we will order them, and we go 2, 2, 2, 3, 3, 4, 4, 4, 4, 4, 4, 5, 5, 5, 5, 7, 7, 8. And we can easily see that the median, which is at the middle, we have 15 here. So to get the rank of the median, you do 15 plus 1, which is 16 over 2, 8. The median is the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. So the median is 4. Now, from the median, we will divide the data set into 2 equal parts. There will be 7 below the median and 7 above the median. So the lower median, the median of the values below the median, is Q1 equals to 3. The median of the values above the median is Q3 equals to 5. The interquartile range is Q3 minus Q1, which is 5 minus 3. The interquartile range or the quartiles are useful in identifying outliers. As I told you, outliers are values that are considered extremely small or extremely large. To determine lower outliers, that is the extremely small values, we multiply the interquartile range by 1.5 and subtract it from Q1. All values below that number is a lower outlier. Now, if we add it to Q3, all values above the number we get is an upper outlier. So, commonly used in exploratory data analysis, which is an aspect of statistics, is the 5-number summary. The 5-number summary consists of the minimum value or the lowest data value, Q1, the median, Q3, and the highest value. So the quartiles are Q1, Q2, Q3. Those are the 3 quartiles. The lowest and the highest value add the other 2 numbers. That makes up the 5-number summaries. So if you are given a set of data and you are asked to identify the 5-number summary, that simply means what is the lowest value, what is Q1, Q2, Q3, and what is the highest value. This 5-number summary can be used to construct a box and whisker plot. The box and whisker plot consists of making a graph, as you can see on the PowerPoint. And starting from the lowest value, you get to Q1, the median, and then Q3, and the highest value. This box is useful in identifying the nature of the distribution, whether it is symmetric or skewed to the left or skewed to the right. When the median is at the middle of the box, the data is approximately symmetric. When the Q2 or the median is at the lower part, it will mean the data is skewed to the right. If it's at the upper part, the median is skewed to the left. Sometimes a horizontal box is used rather than a vertical box. So I will quickly use Excel to construct a box and whisker plot. So the values we have are 5, 3, 5, 2, 4, 7, 7, 4, 3, 4, 5, 2, 5, 2, 8. So these are our values. So I will highlight these values, click Insert. And I'm looking for a graph that can be used for a box and whisker plot. Let me see here if there could be some more graph here. This is it here. So, and then I have my box plot.
Hey, I don't think we can see Excel. If that's
You
what you're
cannot see
working
Excel.
on. No. Okay, I can see it now.
Okay. Thank you for letting me know. So I entered the data values on Excel. Those were the data values that we used to find Q1, Q2, Q3 on the previous example. I can have both PowerPoint and Excel. You will not be able to see, but all what I copy from the PowerPoint are these values. I'm waiting for you to enter the values. If you are done, you let me know. In case you are entering the value. Do you have the value on Excel? Can you see Excel, everybody now?
Yes, we can.
Yes.
Okay. Are you using Excel? If you are not using, I can continue the work. Is anybody using Excel to do the same thing?
Yes, I inputted my data already.
You have your data already?
Yes.
Okay, you highlight the data. Highlight the data and then click Insert here. So you will see several graphs here, but you are not seeing a box and whisker plot. So if you see at the corner here, there is an option to see all chart. So if you click on it, you will see all chart here. Now, when you come down here, you see box and whisker. Click on it. And then you have a box and whisker plot. So this is the box and whisker plot. From it, you can see that the minimum value is 2, the maximum value is 8. Q1 is 3, Q2 is 4, and Q5 is, and Q3 is 5. So that's what we have here. So that's it for chapter 3. We learn how to find averages, mean, mode, median, mid-range, variation, variance, standard deviation, and range, which you knew already. Coefficient of variation, Chebyshev theorem that gives us the minimum proportion of values within K standard deviation. And then quartiles, which is part of exploratory data analysis. Percentiles, quartiles, the interquartile range is a measure of variation as well. And it can be used to determine the outliers by multiplying it by 1.5, add it to Q3, subtract it to Q1, subtract it from Q1, and then take any value that is outside the range that you get as outliers. For the few minutes, I just quickly want to go over the project if there is no question. Anybody has a question for what we have done so far? So for your project, you are going to be in groups of 2 to 4 students. You will choose a topic. For example, you can decide your topic is how long you spend sleeping, and people are going to give you values. I generally encourage you to use quantitative data because there is not too much you can do with qualitative so far. How many siblings do you have? How often do you maybe visit the doctor every year? And maybe how long can you afford to drive? For how long you can think about any type of information you might want to get from individuals, at least 30 of them, which will provide you with a number. So that is the first question. Collect at least 30 data values. Evidence for collecting data value is listing the values. So that is, you get full marks by listing the value, you get full mark for collecting data. Don't just say, I collected the amount of time people spend maybe driving or sleeping or eating or whatsoever. Then organize the data into a number of class of your choice, minimum of 5, maximum of 8. So if you collect 40 data values, you might want to use the steps in constructing data to organize your data into 5, 6, 7, or 8 classes. You choose in your group how many classes you want. You remember you need to find the width divided by the number of classes you have decided to use, and find the first class, second class, make class boundaries, make class midpoint, use Excel to determine the frequency, make a cumulative frequency. So those are the type of things that I'm looking for. And then you can use a graph such as a histogram or an ogive. If you happen to, generally I want to see a histogram at this point. I say a graph of your choice, but I would prefer a histogram. Then based on that histogram, you can make a conclusion whether it is symmetric, skewed to the left, skewed to the right. Then use Excel to present a statistical summary of your data. That is, you are going to enter your data on column A of Excel as I did, and then use descriptive statistic to find the mean, the mode, the median, the standard deviation, and so on. And now you will write a brief a summary or a report of your project. The reason why you choose the topic, what motivated you to choose that topic, who did what in the project. If you are 2 and you divided the work, you will say, Alvin collected data and organized it, and then George used Excel to present the data on a graph and to do the data summary. Data summary here is not writing the report. Data summary is mean, mode, median is what we get from the Excel output. Then what have you learned from your project? you can say, for example, we learned that the distribution of time people sleep is approximately symmetric, or is skewed to the left, or is skewed to the right. We learned that the mean of the number of people sleeping is this, or we learned that at least 100% of people are already within one standard deviation from the mean. So you can just include that little part of an addition of your own. But the most common observation is the nature of the distribution, whether it is symmetric, skewed to the left, and skewed to the right. That is what I'm asking you about the project. I encourage you to do more than 30, but at least 30. And especially if you are more than 3 in your group. So I gave an option because you are doing this study online. You may want to go online and find data. If you go online to find data, you can do the same thing. But if you are doing it online and it's not natural data that you collected from individuals, I want you to have at least 50 values. And then you can do the same work. Any question about projects? If you are doing B, that is when you are collecting your data from online, there is another question here. What proportion of values are within 2 standard deviations from the mean? If you like, you can use that if you are doing A, as you are, what have you learned? You can just give me the proportion of values that are within 2 standard deviations. So for those who are doing it online, I am kind of imposing this, that you should do this type of investigation. Is it consistent with the Chebyshev theorem? What I mean there is, if you find, for example, that you collected 50 data values and about 30 of them were within 2 standard deviation, or maybe 40 of them are within 2 standard deviation from the mean. 40 out of 50 makes 80%. Is it consistent with the Chebyshev theorem? Yes, because Chebyshev said it should be at least 75, and you have 80%, so it is consistent. So if you like, you can include this question on your choice A to answer what have you learned from your project. But when you collect data the way you do, not online, I just expect you to say anything more based on the result of your work that you did on your project. What have you learned from your project? Any question? Okay, that is it. Thank you for showing up.
Thank you.
Thank you.
Thank you.
You're welcome. Thank you.